All right, there we go. Okay, so we're going to, as we talked a minute ago when we were going over our Chapter 14 quiz, this lesson today is really going to be very, very similar to a lot of that. I'm just going to kind of practice it some more, solidify what work you actually have to show you a shortcut in the calculator, and do another formula situation that is on the formula chart. So, homework-wise, you'll end up having pages 46 and 47, so 2 pages of practicing these geometric probabilities. All right, here we go. Page 43 in your packet. Chapter 17, Notes, Part 1. So what we have here is some rules or some conditions, some things that have to happen for us to have what we're learning today and tomorrow, geometric and binomial. Now, the thing is that, you know what? These have been occurring since before Thanksgiving. Since in chapters 14 and 15, we just didn't actually talk about it and consciously talk about it. But I must bring this to the forefront. I must say, hey, here are the conditions that have to be happening, because you could have some problems that say, which one of these isn't geometric or binomial? Okay, which one of these doesn't meet the conditions? Okay, so these are Bernoulli trials. You don't have to know that vocabulary word, really. We're going to use these mnemonic device of bits or bins to help us remember the criteria. So the first criteria is binary. B stands for binary. And what do you know about the word binary? 2. So in order for these to work, in order to be able to do these problems, you have 2 choices only, a success or a failure. You know, for example, it's green or it's not green. You get stopped at the train or you don't get stopped at the train. You're left-handed or you're not left-handed. Okay? All right. So there's that. The I in bits and bins stands for independent. And what do we know about independent? Yes, and I expected you to say one doesn't affect the other, and I was just going to go, wrong. You cannot say one doesn't affect the other. What is it? The fact that one event happened, look at there, does not affect the probability or the rate of the other event. One doesn't affect the other is no go anymore. That's lazy words. The fact that one event happened does not affect the probability of the other event. Now, the next thing is the only difference between these 2 mnemonic devices, a T or an N. And that actually is going to be the difference between today's lesson and tomorrow's lesson. Today's lesson they're both about the number of trials. They're both about the trials. You know, like you want 3 things or you want 4 things or whatever. Geometric, the trials go until a success. Geometric, the trials go until. Get that T? Geometric, the trials go until a success. For geometric, the trials go until a success. But tomorrow we'll talk about this thing called binomial, and that will be where you have a set number of trials. For example, I'll say something like, out of 10 cars at the light, what's the probability exactly 3 of them are red? Okay, or whatever, out of the 10 cars. So out of the 10 events or the 10 trials. And I have starred right here to the right. This is the key to tell the difference between if we have a geometric situation or a binomial. So that's the key point we'll pay attention to today versus tomorrow. All right, the last one, the S, is about having the same probability. And I think that's a bit redundant because we know independent talks about that. But I think that it's probably the reason that's pointed out is because, you know, you replace if you say are selecting people to win a golden ticket or whatever, you have replacement where you put the people back into the mix or whatever so that that same probability from trial to trial. So I think that's just stressing that situation. All right, so let's now get going on this. This little paragraph just says, yada, yada, this is the same as what we did in chapter 14. These geometric will go until you get it on the nth thing. And let's do this problem. Here we go. A basketball player has made 80% of his foul shots during the season. Now this says, assuming the shots are made independently, meaning the fact that he missed the first 3 isn't going to mess with his psyche and make him more likely to miss it. I don't know. Okay. So they're saying, assuming it's independent, so the probability is going to stay the same and so on and so forth, find the probability that in tonight's game he does, and then it does some problems. So the first thing you're asked is, let's kind of go through the bits. Let's check our bits in this, or our bins, bits or bins, whichever one. So what would the B stand for? I mean, how would we check the binary situation here? Is it binary? What's happening? What are the 2 choices? Good. It is binary. He makes it or he misses it. Good job. Okay, and so what about independent? We're pretty much told that, right? Okay, so check. I'm glad we were told that because I don't necessarily know if in real life that is the case. So, plus, sometimes you don't, I don't know. Okay. Like even in baseball, in baseball, right? They have different, your percentage for runner when you have runners in scoring position is even different than they keep that track. So it's like, why aren't you that good all the time? Why do you have to have a higher percentage when runners are in scoring position? Runners in scoring position. All right. The T going until the first success. I couldn't really say because this is just going to depend on the problems down below. So whatever on that. But what about same probabilities? I went ahead and I just listed our probabilities that are staying the same from trial to trial. What are they? Probability of making it was 80%. Probability of missing it was 20%. Okay. So this probably is going to be one of the only times I tell you to write down the bits or bins or whatever. But I just wanted to bring that to the forefront because I know of a particular problem. Even on the review, it says which of these situations is not binary or not geometric or binomial. Okay, moving on. I want you to take a few moments and do the next 3 problems, B, C, and D. You don't have to do E, but take a few moments, do B, C, and D. Go. I think I'm ready to see how we're doing on those. So we did pretty okay on this one. He misses for the first time on the 5th attempt. So I am putting this miss right here on that 5th spot. Okay. Now what I have over here in red is so what I have in red is a shorter way of writing the same thing, but you can write what's in blue, and then there's your multiplication. If you multiply that out, is 8.19%. Okay. Then the next one, he makes it on the 4th. So miss, make. So you could do that, 0.2 to the third times 0.8. Okay. Now, here seems to be the one we were struggling with. You want to make it on one of the first 3 shots. So, how would I write out making it on the first shot? No, just 0.8. How would I show making it on the second shot? 0.2 times 0.8. See, this is making it on the first shot. This is making it on the second shot. And this is making it on the third shot. So because it says making his first basket, that was the key as to why we don't put those 2.2s behind it. Making the first basket on one of the first 3 shots. Now, what I want to do at this point is show you a shortcut way of how to write a sequence such as this. Because we're going to end up having things where you might say, like, what's the probability you get it on one of the first 10 attempts? Or it's one of the first 10 people. Do you want to have to write out all of those little sequences there? Heck no. So let me show you how you can write this as here's the shortcut way to write this out. What you do, and I'm actually going to put this on the next page. Let's see here. So the way you will write out a sequence of events is we will include the first event plus ... plus the last event. So that way you only have to write the first one and the last one, and you're indicating in the middle that that's a continuation of the sequence, so you don't have to write them all out. So the way I would have written this problem in shortcut format is I would have said the first one was a success, 0.8, up to, didn't I have 2 failures and then a success? Okay. So that plus ... plus the last event. So that's how you would write it as a shortcut, and then you can just put equals your answer. And in a little bit, we're going to show you some calculator strokes that will be really easy to compute this, because it gets lengthy if you have a whole lot of things in the sequence. Okay. All right, so there is that. Now, this last one says, how many attempts do you expect him to make on average before he misses his first shot? And with what standard deviation? Okay, well, guess what? That is going to actually, anytime it's asking for this situation here and with what standard deviation, it's a formula. And so we're going to take a look at the top of the next page here. And we're going to talk about all of this here. So let's do that. Okay, so first of all, this part that I'm highlighting in yellow should look familiar. What does that, when did we use that? Okay, it's the generic addition rule and the given that rule. Okay, so we did, this was the ORs, when you have overlap, and the given that. We did this on our last quiz, and I let you see this because it's available to you. All right, this next part is chapter 16, and we're going to actually do that after Christmas, okay? So we don't have to do not this yet. No, that yet. Now let's look at these next 2 sections. The next section says binomial, and the next section after that says geometric. Okay, well, binomial we will learn tomorrow, and that is where we have a set number of trials. So I say, out of 10 cars at the stop sign, what's the probability exactly 3 of them are red? Okay, but what's our trigger for a geometric type problem? We go until. Geometric trials go until. Okay, so now here's the next thing. So this is a little vocabulary thing that I found. I made a little song out of it last year because my students would read a problem and then just like not hear the vocabulary of this word expected. And that's what the question asked on the previous page. It said, how many shots do you expect him to make until he gets a miss, or whatever it was that it was asking for? And so I want you to write this in here. Expected value, how many do you expect, is the mean. So that's saying, on average, what do you expect to happen? So expected value is the mean. Expected value is the mean. And then last year's formula chart did not have this geometric formula on it. My students had to memorize it, so that's why I had made a song also. Geometric 1 over p, binomial n times p. So that was our little ditty for that. But in doing so, students remembered this wording that expected value is the mean. And then they would go to this formula chart and do their math. What do you notice here to the right of the means? What are these things here? Yes, so there's our standard deviations. So here we have the means, and here we have the standard deviations. Okay? So let's answer the question on the previous page. It said, let's see, how many attempts do you expect him to make on average before he misses his first shot? So I need to use the miss probability. What's the miss probability? Okay, so the probability of a miss is 0.20. So let's do this. Expected value is the mean. Expected value is the mean. Geometric 1 over p, binomial n times p. So it's just 1 over 0.2. And if you multiply that out, we get 5 shots. So I expect him to make 5 shots on average to get that first miss. So he gets that miss on that 5th shot. Now, at this point, I want to also mention to you that, do you know what? These means can be a decimal value because they're an average. So if it had come out to say 4.5, it's just an average. On average, how many shots is he going to have to make? About 4.5. So is he ever going to make 4.5 shots? No. But sometimes 4, sometimes 5. It's going to be, average out to 4.5. So an average can be a decimal. Average can be a decimal. Okay, let's do the standard deviation. So our standard deviation formula was square root of 1 minus p over p, which in this case is this. When you plug them in, that's 4.47 shots. Standard deviation. All right. Okay, very good. So that's the second thing. The last thing is a calculator tricks to make it easier for you. So let's do that. So let's take a look. We're going to learn about a calculator steps, geometric PDF and geometric CDF. Do you remember whenever we've seen does that CDF sound familiar? Norm CDF, right? We've done norm CDF, okay? Well, we're going to do geometric. And guess what? This is just going to make it easier in doing all the little buttons on your calculator, okay? Could you do it all by hand? Yes, you could. But this makes it easier if you want to use it. Do you have to? No. So first thing I want to point out to you is that the P means in a particular place. It's a point estimate, like a particular place that success occurs. Geometric PDF, exact place of the first success. Geometric PDF, exact place of the first success. Okay, and so let's find that on our calculator and do that with our problem over here. Let's go to our little guy who's our little basketball player. Let's go to our little basketball player, and we want to do this first one, which is he misses for the first time on the 5th. So here we go to our calculator. We're going to go distributions. That's under second vars. Okay, so go to second vars. And there's our good old trusty friends, norm CDF and inverse norm. Geometric is actually at the bottom of the list. So if you go up, it'll take you to the bottom of the list. And look at there, geometric CDF and geometric PDF. So I'm going to do PDF because I want the success to occur in the 5th spot. Exact place of the success. So what is it wanting? Is it wanting a miss or a make? I think it says a miss. Put a miss in the 5th spot. So I need to put the miss probability. So if you have the menu that shows up, then the probability is 0.2. And then underneath that, the line says trials. Where do you want that to occur? In the 5th spot. If you don't have the menu, then you put comma 5th spot. And then we hit the button and bam, right there, calculated it all out. And that's the same thing we got when we had previously computed it by hand by multiplying all that out. Okay, so do this next one in your calculator. Figure out what you would write out there. This one I'm putting 0.8 in the 4th spot. So there's my 0.0064. Easy peasy. Okay. Now, this next one is really handy because it is all of that sequence of events. Now, these 3 items wasn't too bad, but what if you had 15 items in a sequence? I mean, that's just ridiculous. So guess what it is called over here? It is called geometric CDF. What do you think that C stands for? Cumulative. So it will add up the successes on or before that trial. So I want to accumulate the first success anywhere on or before the 3rd trial. So in that problem, part D on the previous page, we're going to do geometric CDF of, what do you think? How's this going to go? The geometric CDF, and I want the 0.8 to occur for the first time on or before what? The 3rd trial. So if I do that here, second vars, geometric CDF, I want the 0.8 to occur on or before the 3rd trial, and voila, there's your 0.992, and you didn't have to do all of that multiplying and adding together. So that makes it nice and handy. Okay, we have just a couple of minutes. Let me have you try these. See if you can't do these in one per minute. Suppose a computer manufacturer rejects. Okay, do 1 per minute here. So what I have written here in red is like the work that has to be shown. So this is the shortest I mean, you could write it out in lengthier ways, but this is the shortest it could be shown. And then I go to my calculator and I like put it in this way to get the answer real fast, and I get my answer like this, okay? You do not, this over here, you do not have to write. This is just FYI for your information. What I have in red is what was required. And this one, by the way, was 0.09608. On this last one, you used the formulas. 1 over P, and then the standard deviation formula. So again, pages 46 and 47 for homework. Okay? All right. Thank you, guys.